Hello guys, Unreal Academy here and welcome back to the sixth part of the Portal Gun tutorial series. In my previous video, I showed you how to set the player's rotation to face forward upon teleportation, and in today's video, I'm going to be showing you how to retain the player velocity so that the player continues moving forward when the player is teleported. To showcase what I mean, I have placed two portals, Portal 1 and Portal 2. Now, when I hit play, I'm going to start falling down and my Z velocity will increase. And when I get teleported, instead of moving in the positive x-axis, I will start falling down. Hit play. You can see I kept falling down instead of going forward like in the game Portal. Now to fix this, open up your Portal 1 blueprint. Open the set player velocity function that we created in the first video. Get the cast to first person character variable and search for get character movement. Scroll to the bottom and just get character movement. And then we are going to set max acceleration to double the default value. For me, the default value is 2048, so I'm going to set it to 4096. We do this so that the player has more control over where he's moving. We're going to again cast to first person character, get cast to first person character, and we're going to call the function store velocity. Double click to open this up. In the components menu, scroll down and get the character movement component and search for get velocity to get the player's velocity. Scroll down, get velocity. Now store the velocity variable in the variable that we created called player velocity. Plug it in here and hit compile. Now go back to your Portal 1 blueprint. After storing the velocity, what we're going to do is we're going to store the Portal 2 forward vector, which is stored by default in the first person character. So get cast to first person character and get Portal 2 forward vector, and store it in the local variable Portal 2 forward vector. And now call the function set velocity according to forward vector. And hit compile. Open the set velocity according to forward vector function up and do a branch check. Branch. Get the Portal 1 forward vector. Split the struct bin. Now if x equal float, x equal float 1, or x equal float -1, do a boolean check or boolean check and plug it into the condition of the branch statement. Now basically what this does is tells us where the Portal 1 has been spawned. If it has been spawned in the x-axis, the Portal 1 forward vector will be either 1 or -1. This will mean that the portal has been spawned in the x-axis, and therefore the player has to move in the direction of either x-axis or the negative x-axis, so the player's velocity will be increasing in the x direction. And now get the Portal 2 forward vector and split the struct bin. Search for equal float, move it here, Control-C, Control-V to paste it, plug this inside here. Now we're going to be checking where the Portal 2 has been placed so that we can set the player's velocity accordingly. Now, if the Portal 2 forward vector x is equal to 1 or equals to -1, meaning that it has been placed in the positive x-axis or the negative x-axis, do a boolean check or boolean and plug it into the condition of a branch statement. If this is true, that means the Portal 2 has been placed in the x-axis. So what we're going to do is cast to first person character, and then we're going to launch the character with the velocity that we're going to calculate based upon what we stored in this function, store velocity function. So what we're going to do is cast to first person character and get player velocity, split the struct bin. Now since this statement has been executed, this means that the Portal 1 has been placed in the x-axis. That means that the player's forward velocity will be x. So we're going to get the player velocity x, get its absolute value, meaning we're going to ignore the sign and just get the value. So if the player velocity in terms of x is -500, this function will only return 500 and negate the negative. Then we're going to add float plus float, add the variable velocity addition, its type is float, to the ABS. Why we're doing this is because so that we can push the player a bit forward upon teleportation. The velocity addition will be something like 100. You can set it to as much as you like. And then we're going to search for multiply float into float and multiply it by the Portal 2 forward vector and split the struct bin and plug this in the x, because the Portal 2's forward vector is x. Therefore, we're going to move the player in the x direction. Check these two boxes. What these two boxes ensure is that the player's velocity gets set to the velocity that we have defined over here. Okay, so now copy this piece of code and paste it below here. Plug in the false of the previous branch into execution pin of the next branch. The change we're going to make is, instead of getting the Portal 2 forward vector x, we're going to get the Portal 2 forward vector y, because in this step, if the Portal 2's forward vector is not x, that means it must be y or it must be z. So in this step, we're going to check if the Portal 2 is facing the positive y direction or the negative y direction. If it's true, we're going to get the player velocity x because the Portal 1 has been placed in x. add it to the velocity addition to push the player forward and multiply it by the portal 2 forward vector, so that if the portal 2 is facing the negative y-axis, the player's velocity will be negative 500 in the y direction. So the player will move in the negative y direction. If it's the portal 2 is facing the positive y direction, then player's velocity will be 500 multiplied by positive 1, which will allow the player to move in the positive y direction. Now, instead of launching the player in the x-axis, we're going to launch velocity y. We're going to plug it into the launch velocity y so that the player launches in the y-axis, and hit compile. Copy this code again and paste it below. Plug in the false of the previous branch into the execution pin of the new branch. And this time, instead of getting the portal 2 forward vector y, we're going to get the portal 2 forward vector z. And instead of launching the player into the y-axis, we're going to launch the player in the z-axis. And just hit compile. And now let's test it out. If the portal 1 has been placed in the x-axis, this code will work. Let's play. Now when I teleport, I should be moving in the positive y-axis. As you can see, I moved in the positive y-axis. And now let's see what would have happened if this function was not set up. Compile. If I play. Now the player is moving in the negative x direction. So when the player gets teleported, the player keeps on moving in the negative x direction. So this is what this function can do if used properly. Another thing to do is, instead of using the variable velocity addition when we're launching the player in the z direction, we're going to use the velocity addition z vector variable in place of the velocity addition, and set the velocity addition z vector to be something like 350. This is so that when the player gets teleported to the second portal, the player moves a bit up, and then when the player falls down, he gets teleported back. Let me show you what I mean. When I hit play, portal 1 has been placed here, portal 2 has been placed here, right? And now when the player will get teleported, he will jump a bit up and then fall back down here. If this was not implemented, here's what would have happened. Play. The player would have teleported and then started to stand upon the portal, which would remove the illusion that these are portals. This is why I'm using a separate variable for adding to the player velocity when the portal 2 has been placed in the z-axis. So ensure that the velocity addition z vector is something like 350. Let me comment this node and hit compile. Copy all of this and paste it below here. Now we're going to do a branch check. If the portal 1 forward vector is equal to y, then this piece of code is going to get executed. And since the portal 1 forward vector this time will be y, that would mean that the player is moving in the direction of the y-axis. So instead of getting the player velocity x, we're going to get the player's velocity y for every instance. Do this for every instance, y and y, and hit compile. And plug in the false of the previous branch into the execution pin of the new branch. Copy this code again, paste it here. Plug in the false of the previous branch into the execution pin of the new branch. And this time, instead of checking if the portal has been spawned in the y-axis, we're going to check if the portal 1 has been spawned in the z-axis. If it's true, this is going to get executed, and instead of getting the player velocity y, we're going to get the player velocity z, because the player will be moving in the z-axis to get to the portal 1. Do the same for every instance here, and hit compile. Now it should work for every axis. Let's see if it works. You can see it's working wonderfully. Now let's copy all of this code here. Copy all of this code, open up the portal 2 blueprint, and go to the function set velocity according to forward vector, and paste it all here, and plug in this function node into the execution pin of the first branch. And instead of getting the portal 1 forward vector, we're going to change it with the portal 2 forward vector. Connect the x into the new x. Do the same here. Y into the new y, and z into the new z. Do the same for these instances, and hit compile. So open up the portal 1 blueprint and open up the set player velocity function. Copy this piece of code here and paste it over here. And instead of getting and storing the portal 2 forward vector, we're going to get and store the portal 1 forward vector. Get portal 1 forward vector, and also change the portal 2 forward vector to portal 1 forward vector, and connect it here, and hit compile. And now let's see if it works. Oops. You can see I got thrown forward. Let's try it again. So yeah, it works. Now there is one problem related to rotation, player's rotation. The reason why the player's rotation is not set properly is because instead of getting the portal 1 rotation, I'm getting the portal 2 rotation. So to fix this, just get portal 1 rotation and replace the Z into this, hit compile. And now if I play and place the portal here, portal here, you can see that velocity works as well as the player's rotation. Let's see it in action for some other sides as well. Working here as well, and here as well. Works here and here. So everything is working smoothly. Now I'm going to address one issue with my blueprint here, is that after a delay of 0.2 seconds, we're setting the can teleport variable to false. What happens if before that 0.2 seconds, this portal 1 blueprint gets destroyed? What will happen is that this code will not execute, and so can teleport will be set to false indefinitely. So to fix this, what we're going to do is move all of this into the first person character blueprint. So open up the first person character blueprint, go to the event graph, create a new custom event, and name it reset can teleport. Now drag out this execution pin and search for delay. And after a delay of, let's say, 0.2 seconds, we're going to do a branch check. Get can teleport. If it's false, then we're going to set can teleport to true. And hit compile. And now you cast to first person character and call the custom event reset can teleport. Control, press this and plug it into the execution pin of this. Straighten up, delete, and delete. Compile. Open up the Portal 2 blueprint, go to the event graph, and do the same here. Delete all of this code. Get the cast to first person character and call the event can teleport, reset can teleport. Control drag into the execution pin. And now hit compile. Go to the first person character. Instead of using delay, you're going to use a retriggerable delay. And hit compile. Now if I play, you can see my function works wonderfully. Although this works, there is one huge problem, which is, let me show you. The player's velocity keeps getting increased if both the portals are placed on the ground. This is because of this code written here. When the portal 2 is placed in the z-axis and the portal 1 is also placed in z-axis, then what happens is we do a branch check if this is true. If both the portals have been placed in the z-axis, then we add to the velocity, which is 500. So when the player is falling down from this height and goes into portal 1, the player's velocity will be 500 when coming out of portal 2. And when the player goes up 500 and goes back down with velocity 500, an extra 500 gets added to the existing 500, which makes it 1000. So the player's velocity gets increased to 1000, and then when the player gets teleported, the player starts falling down with the velocity of 1000, and another 500 gets added to the 1000, making the player's velocity 1500. This keeps on increasing, and thus the player's velocity keeps on increasing as well, and the player keeps on going higher and higher. To fix this, what we can do is we can do a branch check to check the velocity of the player. If the player's velocity is greater than 500, then we will not add 500 to the player's velocity. And if it is less than 500, what we'll do is we'll add 500 to the player's velocity so that the player can overlap the trigger and get teleported. So open up your Portal 1 blueprint and delete this part of the code here. Move this right here. Now what we're going to do is we're going to get player z velocity, apply the ABS function on it, and then we're going to check the value. So do check if it is less than equal to 500. We're going to do a conditional check here, branch. If it's less than 500, then we're going to set index to 0, which means that the player's velocity is less than 500. So we're going to be adding 500 to the player's velocity, and if it is greater than 500, this condition will return false. So we're going to set index to 1. Connect this into the execution pin of the launch character. And now what we're going to do is we're going to get the Portal 2 forward vector. So we're going to get Portal 2 z forward vector, multiply it by a float, so float into float, and this will be velocity addition z vector, get velocity addition z vector, so that when we multiply the forward vector of the Portal 2 by the velocity addition z vector, so that when we set the player's velocity, the player keeps on moving forward. Now drag this out here and select. So option 0 will be selected if this condition is true, and option 1 will be we're just going to set the player's velocity to whatever it currently is. So get the ABS. We're going to add float plus float. We're going to add 50 to it to nudge the player out a bit, and then multiply the result by the forward vector of Portal 2 so that the player keeps on moving forward, and plug it into the option 1 of the select node. And the index will be equal to set index variable that we created here. Return value will be plugged into the launch velocity Z of the launch character node. And let me just clean this up. Now copy this part of the code, all of this, Control C, and paste it in the Portal 2 blueprint. Delete this, move this further ahead, paste it here, connect these nodes, and true of this into the branch execution pin. Return value into the launch Z velocity. After adding 50, we're going to multiply this and plug this in here and hit compile. Play. Let's see it. You can see we're falling down and then getting teleported. So the code is working now. Now let's see what happens if we fall from a height. As you can see, our velocity is keeping constant and it is not increasing. So this piece of code works for both ways. And that's it for today's video. I hope you guys liked my video. In my next video, I'm going to be showing you how to only spawn the portal in places where there is enough space. So currently the portal will spawn anywhere. Let me show you what I mean. Like if I shoot on this, it will spawn here. If I shoot in the corner, half of the portal will be outside or not visible. I'm going to be showing you how to automatically move the portal so that the portal's position is like this and not like this. If you like this video, please do like, share, and subscribe for more. See you in my next video. Bye.